Hello, my name is Kyle Friend, and I'm going to be telling you today about units. So in chemistry, class or lab, we'll often ask a question and there'll be a numerical response. Maybe it's 58. You say, I've got 58. We'll say 58 what, right? Because we care about units. We care about relating numbers to the physical properties of something that we're measuring. So maybe you've got 58 grams of a salt. Or maybe something is 58 millimeters long, right? Maybe something is at 58 degrees centigrade, right? So we care about quantitating the amounts or the temperature or whatever of something. And so we have to relate a number to the physical properties of something using these units. So it's common to speak in terms of SI units. So these are a set of standard units that people use, and these units correspond to different physical properties that you might be able to measure. So we'll start with every chemist's favorite unit, which is something that allows us to quantitate the amount of something. And this is the mole. And the mole it's almost like a dozen, right? It refers to a number of things. So where a dozen is the number 12, a mole corresponds to 6.022, and those numbers kind of keep going, times 10 to the 23rd, let me clear that up, 23rd of something, right? So if you have 1 mole of zinc, you have 6.022 times 10 to the 23rd atoms of zinc. So that's one thing that you might want to measure. We can also measure mass. And here the SI unit is the kilogram, although it's very, very common to speak in terms of grams. So we can weigh something. We can measure the mass of something. We have length. Here the SI unit is the meter. We have temperature. Here the SI unit is in Kelvin, and Kelvin can never be negative. The lowest temperature of Kelvin is 0, that's absolute 0. We'll commonly think in terms of degrees Celsius in a chemistry lab. Degrees Celsius can be negative. You could be 5 degrees Celsius below 0, which means you're 5 degrees Celsius below the freezing point of water. But Kelvin and Celsius are two ways of quantitating temperature. And then we also have time in seconds, right? What you will note on this list, I'll draw a line under it, so we don't have anything for volume. Well, technically volume is the length cubed, and so we could represent volume in terms of meters cubed. That would be one way of doing this. It's actually common to use a different unit for volume, even though it's not an SI unit, and that is the liter. And 1 liter corresponds to 1 kilogram of water. It's a certain volume that we can easily quantitate. Okay, so we also will use liters for volume. And in terms of later measurements that I'll talk about, we'll see liters used much more frequently than length cubed. So these are our SI units and one non-SI unit. What you might already know, and we already saw an example of this, is that there are also prefixes that we use with these units. Right? When we talked about the SI unit for mass, we spoke of the kilogram. Right? Well, that little k corresponds to the prefix kilo, and that in turn corresponds to 10 to the third, right? So a kilogram is 1,000 grams. But we have other prefixes that we'll commonly use. We'll commonly use centi, as in, say, centimeter. That's 10 to the minus 2. Milli, it's 10 to the minus 3. So obviously we're getting very, very small here. Micro. So maybe a micromole. That's 10 to the minus 6th. And micro here is represented by a mu, right? So that's the Greek letter mu. 10 to the minus 6. We also have nano. Maybe like a nanogram, right? It's 10 to the minus 9. Pico. So we're getting down here pretty small, like a picosecond. It's 10 to the minus 12. And femto. Maybe again a femtosecond. This is 10 to the minus 15. Right? So these are all prefixes that we can attach to our units so that we can think in terms of very, very small quantities, right? So 1 nanogram is easier to say than 1 times 10 to the negative 9th grams. So let's work with prefixes very, very quickly. Let's do a prefix conversion question. So here's my question. How many micromoles are in, let's clean that up, in 14.57 millimoles of NaCl. So that's sodium chloride. All right, so how many micromoles are in 14.57 millimoles of sodium chloride? So in a later video I'm going to show you a few more examples of this, but to do this kind of unit conversion we'll do something called dimensional analysis. So we'll start over here. So we have 14.57 millimoles, and we'll represent that as a fraction. And what we want to do is treat our units almost like the variables in algebra, where we can cancel them out. And so maybe you know how many micromoles are in a millimole, but let's sort of like spell this out to be completely explicit, right? So there are 10 to the minus 6 moles in, oh shoot, we're going from millimoles. So 10 to the minus 3rd moles in 1 millimole. So sorry, I misspoke there. We have 10 to the minus 3rd moles in 1 millimole. So now we can cancel our millimoles, right? Because we have 1 in the numerator, 1 in the denominator, so those cancel. And we want to get micromoles here in the end. So 1 micromole is equivalent to 10 to the minus 6th moles, right? Our moles cancel. And now the unit that we're left with is this unit here, which is micromoles. So we're good. All we have to do is take 14.57, multiply it by 10 to the minus 3rd, and then divide that by 10 to the minus 6th. And when we do that, we get 14,570 micromoles, right? And so this is a nice way of doing unit conversion. We do this trick. It's called dimensional analysis to sort of work through these kinds of problems. So that's it for this short little video on units, and I will see you on the flip side.